Our paper presents a method called wormhole learning. Typically, to enlarge the operating domain of an object detector, more label training data is required. In this work, we show that thanks to temporary access to an auxiliary sensor with certain invariance properties, we can extend the operating domain of the original detector. Wormhole learning consists of 3 steps. We first start off with an RGB detector trained only on daytime data. In step 1, we perform transfer learning from the RGB domain to the infrared domain. Given access to paired video streams from an IR and RGB camera, we can train a detector in the IR domain using labels generated by the RGB detector. In the second step, we can leverage invariance of the infrared camera to changes in illumination to operate at night. In the last step, the sensor switch roles and the RGB detector is trained based on the labels from the IR detector. This whole process is what we call wormhole learning. In the first step, we start with a network trained on daytime data only. Using this network, we generate labels and transfer those to corresponding IR images during the day to train an infrared detector. By exploiting approximate invariance to illumination of the IR camera, we are able to detect objects also at night. You can see from the video that images and object detection performance during day and night are similar. As before, we generate labels at night using the IR detector and transfer them back to the RGB domain. Using the joint data of annotations during daytime and labels generated in a semi-supervised fashion at night, we train the enhanced RGB detector. In this comparison, we can see the original detector on the left and the enhanced detector trained using wormhole learning on the right, performing at night. Due to not total absence of illumination, the original detector is sometimes able to detect objects, but with a very low confidence value. The enhanced detector in turn has learned new representations of objects and thus is able to detect more objects at night. So from this experiment we can see how these 3 simple steps were implemented. We begin to answer some essential questions to understand wormhole learning. When can we do cross-domain transfer learning and how to make it more effective? What is the information that we can ideally gain during the process? In the paper we provide insights about the wormhole learning process through information theory quantities. Finally, we analyze the interplay between operating domains and sensor representations as a crucial step for effective transfer learning.